All right, so let's think about what you did. You took a piece of paper, and actually they tell me in the problem that my paper I'm using is 12 by 15. So I got a 12 by 15 piece of paper, and I cut out the corners, and I have no idea how big those are. Those are the determining factors as to how big my box is. And I folded up the flaps. These are the folds. Everybody see that? There's my box. So tell me about the volume of this box. How do I find volume again? Of a rectangular solid? Length times width times height, right? Okay. So what's the length of this box? In other words, what's this? This would be the actual length of the box. 15 minus 2x. Very good. 15 minus 2x. And what will be the width of the box, which is actually this right here? 12 minus 2x. And what will be the height of the box when we fold up the flaps? X. Now let's look at that to make sure everybody's clear on it. Everybody okay with that? Okay. So now it says find x so that the box will have a volume of 125. So won't I just put 125 in here for volume? Now, you got a choice here, and neither one of them involve foiling. Do not foil that out. That would be a waste of time. Don't need to do it. We're going to do this on our calculator. If we leave it like this, then we'll put in 125 as one equation. We'll put in all this with the parentheses as the other equation, and look where they intersect. If you prefer, you can take all this with the parentheses, do not multiply it out, and subtract 125. Then you can put that in as one equation and look for the zeros, right? So whatever flips your switch, do it one way or the other. Let's see if you can come up with a value of x. By the way, I'm not sure what window here, right? You can try whatever you've got, but you may have to make some adjustments, right? Because we got some wild and wacky things going on. It's a cube, so at most 3 times, yeah. At most 3 times. So Sir just said, how many times should it cross the x-axis? This is a cube, so at most 3 times. I'm not sure how many times this one crosses, but at most it would be that. Okay, are you finding some answers? I'm not sure which way you did it. Are you finding points of intersection or zeros? One way or the other? All right, let's see what you come up with. I got one of them to be 0.942. You already got the other one, sir? All right, I'll just let you tell me then. I got that one. up here and let's talk about these numbers here. These look okay? So what this means is that if one of you cut corners that were 9.42 by 9.42, and somebody else cut corners that were 3.778, that you would both end up, your boxes would look different, but they would both hold exactly 125. Does that make sense to you? Now I want to talk about this one, because that was actually extraneous. Can somebody tell me why that is an extraneous root? David?
Because if you multiply it by 2, it's bigger than the whole side.
Exactly. This problem has a domain that is possible x values between 0 and 6. Actually. Between 0 and 6. Why? Well, obviously 0, because x cannot be negative, right? And 6, for exactly the reason David said. Think of your paper. If it's only 12 inches across, and you have to cut a piece off of each side, can't be more than 6, right? I can't take 7 inches off this side and 7 inches off this side because I only got 12 inches to work with, right? Yeah. So this is the domain of the problem. So any answer you find, any x value you find outside of that doesn't make sense. Doesn't make sense. So it's entirely possible that when you graph one of these things, you'll get something like this. That makes no sense. That can't be, because it's negative. Okay, everybody all right with that? That idea, if you can think about that ahead of time, that will help you set your window, because if these are the possible x values in the problem, then wouldn't that be x min and that be x max? Yeah, and whatever else happens doesn't really matter, because those are the only ones we can use. Okay, so when the question says, find where x, or find where the volume is 125, these would be the answers right here, right? That's what exactly equals 125. Now, more than 125. All right, well, keep in mind, when you graph this thing, and I don't know, I did it with zeros. If you did it with intersects, obviously your picture is going to look different. But I've got a picture that looks like this, right? Now, where is that more than 125? Now, keep in mind that the equation I put in was all that stuff minus 125, and that needs to be now bigger than 0. Because it was bigger than 125 before, so when I subtracted 125, now I'm looking for where it's bigger than 0. Would you agree with me? So right here. Gotta be in your domain. Yeah, it stops right here. So right there, so the answer where it's bigger than 125 would be 0.942, 0.3778. That's where it's more. It's greater than or equal to, no, more than 125 would be this from here to here, that little section right there. This is where it equals 125. This is where it's more than 125. Now, where is it less, or I should say at most 125? Where is it at most 125? That would be all of this and all of this. So everything from 0 to 0.942, or everything from 3.778 to 6. Remember, your problem ends at 6. Anything after that doesn't make sense. Now, what kind of symbols do I need here? It was at most 125. So this is gonna be a bracket. This is gonna be a bracket. What about 0?
Are you assuming that you have to cut out a box?
It says find the values of x. So if we say x is 0, I don't think we're gonna have a box, right? So I think I'll put parentheses on those. That's kind of a point we could argue forever about. I think I'm gonna go with parentheses. If you wanna go with brackets, you can. Because certainly, if you didn't cut anything out, your volume would be 0, and that's not 125, but you wouldn't have a box either, so.
Yeah, so then 6, I guess.
6 would be the same issue.
Okay.
6, whatever you do to 0, you've got to do the same thing with 6. Because if you took 6 out, you lose that whole side and you don't have a box. Yeah. So I'm not gonna mark it wrong if you, given this question, the way it's worded, if you wanna include those. I don't think that's a good thing to do though, because I wouldn't have a box if I did it. And the whole point of the problem is to make a box, so. Not include those. All right, everybody okay with that? All right, okay, well, there's one more, projectile motion, here we go. Okay, in order to do this problem, we need to have our formula for projectile motion.